We have always wondered, are we alone? For centuries we have looked up at the stars. We have asked the most haunting question of all. Are we truly the only ones? Some say yes, others hope not. But what if that answer just changed? On April 17, 2025, a telescope floating 1.5 million kilometers above Earth quietly sent back data that may rewrite the story of life in the universe. According to NASA, a distant planet named K218b might not just be habitable, it might already be alive. The signs are not vague, they are specific, they are powerful, and they point to something we have never found before. Dimethyl sulfide, this is a gas that on Earth is almost only created by living organisms. Phytoplankton, marine microbes, the breath of oceans, and on K218b. This gas appears to be 1,000 times more concentrated than anything we have ever recorded here. How is that possible? How can we smell the breath of a distant sea, 124 light years away? What kind of planet sends a signal so clear? That scientists begin to whisper, we might not be alone after all. And if it is true, if what they found is real, then this changes everything. Because it means life does not just exist. It means life thrives, even in places we have never seen. Today we follow that signal. From a single molecule, floating in a distant atmosphere, to the possibility of a second Earth, only better. This is the story of K218b and the moment humanity may have touched the edge of the unknown. The story of K218b did not begin in 2025. It started 10 years earlier. In the year 2015, the Kepler Space Telescope, having entered its second mission called K2, began scanning deep space for distant worlds. Over time, it discovered more than 1,200 exoplanets, but one stood out from the rest, a planet that seemed almost too promising to ignore. It was nearly 2.5 times larger than Earth, and almost 9 times heavier. Scientists gave it a name, K218b. 2 years later, another eye turned toward it, the Spitzer Space Telescope. Spitzer confirmed something incredible. K218b lies within the habitable zone of its star. This is the sweet spot where liquid water could exist on the surface, a condition essential for life as we know it. Around the same time, an observatory in Chile used a special tool called the HARPS spectrograph. It measured the density of K218b. The numbers suggested something astonishing. The planet may contain an ocean, a massive one. The excitement grew. More and more data pointed to the same conclusion. K218b might not be a dead rock, it might be alive. Then in 2019, the Hubble Space Telescope made another leap. It detected water vapor in the atmosphere of K218b. Suddenly, the dream of a living ocean world did not seem so far away. Hope became something real, tangible, measurable. But it was not until 2023 that everything changed. The James Webb Space Telescope, the most powerful eye humanity has ever placed in space, turned its focus to this distant planet. What it saw shook the scientific world. There were traces of a chemical compound called dimethyl sulfide, a gas that on Earth almost always comes from living things. Phytoplankton, algae, microbes in the ocean. If this gas truly existed on K218b, and if it was not a mistake, then we might be looking at the first real sign of life beyond Earth. But one instrument alone could not confirm it. The discovery was made using only one camera, the near-infrared sensor on James Webb, and identifying dimethyl sulfide is hard. It can be confused with other gases like methane. The margin for error is slim. So scientists asked a simple but serious question. What if it was a glitch or a limitation of that specific device? To find out, NASA prepared for a second observation. New method, new instrument, same target. On April 17, 2025, James Webb tried again. This time, it used a mid-infrared camera to scan K2-18b once more. The result, staggering, the gas was still there, dimethyl sulfide. Detected again, only this time, its concentration appeared enormous, 1,000 times more than what exists on Earth. This was not just any chemical on Earth. It comes from one source, life. To understand why this gas matters, we need to look at what dimethyl sulfide really is. On Earth, it is produced almost entirely by life. Tiny creatures in the ocean, like phytoplankton and algae, create it when they die and decompose. As they break down, this gas is released. It floats upward, evaporating from the waves, and enters the atmosphere. If you have ever walked along the sea during windy weather, you have smelled it. Dimethyl sulfide is what gives the ocean that salty, familiar, unmistakable scent. But the smell is not what makes it important. It is the gas's behavior. In our atmosphere, dimethyl sulfide is extremely unstable. It does not last long. Within days, it breaks down under sunlight and oxygen. This means it must be constantly replenished. Without a steady source, it disappears, and on Earth, that source is life. So when scientists discovered it on K2-18b, they were stunned. Not only did it exist there, but it existed in an amount far greater than anything on our planet. If the gas breaks down quickly, yet still remains detectable, then something must be producing it all the time. And if that something is biological, as it is here on Earth, then there may be living organisms on K2-18b right now, releasing this gas into the air. This would not just be a trace of life, it would be a signature, a fingerprint, a loud and clear message across space. Something is breathing, but how did we even detect this gas? From a planet 124 light-years away, the answer lies in light. Each time K2-18b passes in front of its star, a small portion of the star's light passes through the planet's atmosphere. This light is filtered, changed, altered. Different gases absorb different wavelengths, and this leaves a pattern. Like a barcode, in the light that reaches our telescope. By studying this pattern, astronomers can read the chemical makeup of the atmosphere, even from unimaginable distances. This is how we found dimethyl sulfide. Not by traveling to the planet, but by reading its light. And what that light told us was extraordinary. A gas that lives and dies quickly, that must be constantly replenished, exists in a thick cloud layer around K2-18b. And if nature works there as it does here, there can be only one explanation: something is alive. To understand what kind of life might exist there, we first need to understand the planet itself. K2-18b orbits a red dwarf star. It is a type of star that is smaller and cooler than our sun. The planet lies very close to this star, about 2.5 times closer than Mercury is to the sun. But because the star is much dimmer, K2-18b receives about the same amount of heat and light as Earth. This is what makes it potentially habitable. Scientists believe it belongs to a rare class of exoplanets, called Hycean worlds. The term comes from hydrogen and ocean, because these worlds are thought to be covered by deep water, with a thick atmosphere made mostly of hydrogen. This is important, because a hydrogen-rich atmosphere changes everything. It can trap more heat, create higher pressure, and support chemical reactions that are different from what we see on Earth. And under the right conditions, it can still support life. Researchers also noticed something else. K2-18b does not appear to have ammonia in its atmosphere. That matters because if the planet has an ocean, ammonia would dissolve into it and be difficult to detect. The absence of ammonia supports the idea that there is water present, lots of it, but not everyone agrees. Some scientists warn that K218b may not be an ocean planet. At all, it might be a mini gas giant, similar to Neptune, with no solid surface. If that is true, then life as we know it would struggle to exist. Or may not exist at all. The surface could be too hot, the pressure could be too great, the chemical environment could be completely hostile. In that case, the gas we detected might come from something non-biological, something we still do not fully understand. One researcher who disagrees with that view is Professor Niku Madhusudhan. He is the lead scientist from the University of Cambridge, and the one whose team first discovered dimethyl sulfide on K218b. He believes the planet is indeed an ocean world, and that it may be teeming with life. According to him, new observations in the next 1 to 2 years will confirm with certainty whether this gas is real and whether it comes from biological sources. Until then, we wait, but the current estimate is already shaking the foundations of science. A 99.7% chance that signs of life exist in the atmosphere of a planet 124 light-years away. If something is alive on K218b, what might it look like? We can only guess, but science gives us clues. Everything on Earth began with microbes, tiny life forms that could survive harsh environments. And the same might be true out there. On K218b, the atmosphere is thick with hydrogen. The pressure is intense. The temperature could be high, but that does not mean life is impossible on Earth. There are organisms that live near hydrothermal vents, where temperatures reach over 100 degrees Celsius. These creatures do not need sunlight. They use chemistry instead. They feed off reactions with hydrogen sulfide. They live in complete darkness, and they thrive. We call them extremophiles, and they might hold the key. If microbes can survive in our deepest oceans, they could also survive on a planet like K218b. Now imagine this. What if life there has evolved further, beyond microbes, to something more complex? The planet may be a deep ocean world with no land and almost no light. That would change everything, because in darkness, eyes are useless. Life there might not see, it might sense, it could detect heat, feel magnetic fields, or taste chemicals in the water. Some creatures might even glow, using bioluminescence to communicate, just like fireflies or anglerfish. But there is something else. A strange possibility, because the atmosphere is made of hydrogen, and hydrogen is lighter than air. The buoyancy is greater. This means that life could grow larger, much larger. On Earth, gravity and air pressure limit the size of most creatures, but on K218b, those limits might not apply. Imagine giant jellyfish, slowly drifting through warm waters, or floating beings the size of houses, rising and falling in thick clouds. These creatures might move gently, with bodies built to handle extreme pressure, maybe with soft outer shells or dense, flexible skin, like a mix between coral and squid, armored but graceful, strange but alive. And if the ocean is deep enough, some of these beings might live miles below the surface on Earth. The deepest known point is the Mariana Trench, at about 11 kilometers down. But on K218b, the pressure at 15 miles deep could be 2,000 times that of Earth's surface. To survive there, life must adapt. It might develop thick skeletons or tough biopolymers, far stronger than anything in our biology. Some might look like crabs, with heavy plates and hidden eyes. Others could be smooth, like shadows with glowing lines, swimming slowly through the darkness. All of this is speculation, but it is based on one truth. If the gas we detected is coming from biology, then life is already there, and it has found a way to survive, maybe even to thrive, right now, in the ocean of a distant world. Something might be moving, something that breathes, something that does not know we exist, just as we are only beginning to realize that it might exist too. K218b may be the most promising, but it is not the only one. There are other planets, other worlds, each holding a mystery of its own, just 12.5 light years away. There is Teegarden B, a rocky planet, with Earth-like temperatures, orbiting a cool red star, but it is tidally locked. One side is always in daylight, the other in eternal darkness. Yet in between, in the twilight zone, a narrow ring of permanent dusk. Liquid water might exist, and where there is water, there might be life. Farther out, 301 light years away, is Kepler 1649c. It is slightly bigger than Earth and orbits a red dwarf. It too is likely locked to its star, but once again, in that small strip between heat and cold, conditions might be just right. Another world, TOI 700d, lies 101 light years from Earth, unlike the others. This planet may not be tidally locked. It could have days and nights, like Earth does. It receives about 86% of the light Earth gets from the sun. The temperature might be cold, but with a gentle greenhouse effect. It could stay mild enough for oceans to form. Then there are stranger planets, places that seem impossible. GJ1214b is a water world, but the water is not liquid. It exists as a supercritical fluid. Neither gas nor liquid, but something in between. Kepler 70b is so close to its star that it burns at 6,600 degrees Celsius, hotter than the surface of our sun. WASP 76b has a day side where iron vaporizes and a night side where it rains molten metal. Some planets, like J1407b, have ring systems 200 times larger than Saturn's. Others, like PSRJ 17191438b, are made of carbon and may be giant diamonds orbiting neutron stars. There is even a world, TOI 2126. That takes 900,000 years to orbit its star. It floats so far away that it was once thought to be alone in space. And now, for the first time, we have seen something even more incredible, a moon-forming disk. Around a distant planet, PDS-70, see a place where moons are being born, not in theory, but in reality, right now. And then there is KOI 5b, a planet in a triple star system. If you stood on its surface, you would see not one sun, but two. One massive and bright, the other smaller and softer, together painting the sky in strange light. These are not just points on a star map. They are real. They exist. And they remind us how little we know. If K218b is alive, then life is not rare. It is common. It is waiting. It is everywhere. And if that is true, then we are not the exception. We are just one voice in a cosmic choir. We have always looked up and wondered who might be looking back. Now we may finally have an answer, not in a signal, not in a sound, but in a chemical drifting in the air of a world we have never seen. Something is breathing, and it is not us.